Welcome to a new test and teardown video. This time it's a thru oscilloscope, 20 MHz, 2 channels, CS1022. Look how beautiful it is. That is because I spent the last few hours trying to clean it up like this. It was very, very dirty. I couldn't really fix this little problem here. Somebody had a little accident with a soldering iron. I got this last weekend from a flea market, and it was in a free pile of goodies. So yes, I got this for zero money, and the guy there said there was a problem with this scope and he couldn't be bothered fixing it. So let's see what kind of problem that is. So I turned off the light here, and power on off is here. So let me crank on the mains, and there's nothing bad happening. We got an LED, 40 watts. Oh, that illumination seems to be working. Intense. Oh, there's a beam. So that is good. Focus is like that. Ground. Okay, that definitely is not looking good. So that is channel 1. Channel 2 is here. Okay, so all the basic stuff seems to be working. The line here, look how that looks. We got this. Okay, we got hum. Wow, what a nice layout. I am positive surprised. I did not expect this to be so fantastic. This is the first look inside, and look at that shielded box here, completely closed and sealed. Of course, we also got this magnetic shielding in here. A very, very big trace rotation coil. The power supply is here, and it is full of dust and goodies. So I will have to go and use some compressed air and a paintbrush and make it nice and shiny again. But maybe it's one of those capacitors we need to fix, or maybe it's on the other side. We will have a look. So that will be the 2 vertical channels with the preamp and attenuators. I really like the way it's made with this centered tube. There's also a PCB at the bottom, and there's some connectors on that board that connects to this. So that means less cables, less stuff to fool around with. So that will be the vertical amplifier, vertical deflection. That will be the pull-up resistors for the vertical deflection. And of course, that will be the vertical deflection wires. And I don't see any delay lines so far. Maybe it's hidden somewhere else, but so far I don't see it. Other side, the right side of the unit. High voltage switch mode power supply. I think actually this is the, yes, that is how it works. So that is a tripler. Wow, so this one is using a tripler, and that one is the high voltage power supply. It's also full of nasty dust. And again, interconnects with a PCB down there as well. And that will of course be horizontal deflection. And that is the time base switch and all that kind of stuff. Very easy to access here. Now we can clean the switches and all that. Super easy. I wonder how we access that PCB down there. What if I take away the bottom plate here? It's probably interlocked like that. Look at that, pressed into here and stuff. I don't know, maybe it's going to stay kind of stable with that. It is, yes, that is screwed here. Maybe we can, I don't know. Because I want to know what that bottom PCB is doing. So I am still hunting down the ripple on the high voltage. So this is my deflection. And I got ripple on this deflection. That deflection is running on 100 volt, and it's also affected by the 140 volts somehow. I added a little bit of information here so it's easy to figure out what is going on. So that will be the output transistors, the current limit or overcurrent protection, and that is the driver transistor, and that is the op amp, a dual op amp. So that is the two regulated supplies. And if we look at the schematic, it looks a little bit like this. What is not shown on the schematic is this op amp is powered of the plus and minus 15 volts. Minus 50 volts is the reference for both of the voltage measurements. And then you see two driver transistors and then the output transistor. There is a design flaw if you look at the schematic here. If you see the current sense transistor, it takes a little bit of time for this current sense resistor to shut down when there is a short or an overload, and also during each power on, the overcurrent transistor is fighting against the voltage regulation, because voltage regulation senses a too low output voltage, so it cranks up to maximum potential, maximum drive, and then it is using its maximum current to charge all the capacitors in the circuit. But as you see here, there is no base transistor of Q304. So at an event of any power on, short circuit, overload, there is nothing preventing Q304 to blow up its base. So first I thought we had a faulty transistor here, or a leaky transistor here, because I actually also had a missing 140 volt problem while I was measuring around. Then suddenly I didn't have any output. And then I realized, oops, I also don't have any output drive from the op amp. But while measuring on the op amp, suddenly it came. So there's also a loose connection on pin 1 of this op amp somehow. So I think I need to desolder that one as well. And the output capacitor here on the 140 volt, I think that one is without any more value really, because I see a little bit of ripple here, and I can also see that the op amp is fighting real hard to try and regulate the output, and it's not supposed to be that crazy fighting against that. So to get this board out, it's not that easy. I took away the bottom plate, so now we can see this interface board that is here in between the two other boards. Actually quite nice the way that this is made. And this is also how you access line voltage selector. And as you see right now, it is set for 220. I want to change this to 240 because I can see the voltages on the primary sides or the input sides to all regulators is really, really high, and this is only going to just run everything warm, and we don't want that. But I want to try and access that capacitor and probably some of the other capacitors here as well, and see if I can change this. But that is not that easy, right? Because you can see here the front potmeters, they're soldered into that PCB, and that PCB is like screwed onto all this. So to be able to pull this out, I really need to take it to pieces. Yeah, but that is how it is. That was not at all as hard as I was trying to make it. Easy, easy, only a few screws. And here's the PCB. Power supply and vertical deflection board. And here is definitely where I expect to find the problem. So the deflection here is running on 100 volt. And look at that, all those resistors there in series 2 and 2. Just to try and dissipate all that heat. And that is a decoupling capacitor, a local decoupling capacitor for the 100 volt. And that is the 140 volt, it says here on the PCB. So that is what I need to look at. I was looking a little bit on the other side, because now we can finally see the other side. It's actually a beautiful layout, really. Tons of copper. That is good. Big, wide grounding all over the place. Great, great. Let's see, we got some modifications here on those two power supplies. Ooh, so maybe they were replaced. But it looks a lot like a factory modification, because look at that. The black isolation here and all that. It looks exactly like the same kind of isolation all the jumpers they're made from. See, this is a single layer board with all those jumpers, and it's still cheaper to make it a single layer board instead of a 2-layer without all those jumpers. So I had the whole board out. Actually, I changed all the capacitors in the whole power supply without any exceptions. I also changed the op amp because it was, you know, when I measured around here, I poked around and pushed a little bit and then it changed behavior. That was the classic JRC 4558. And that one you can just put in a TL72. So this is what I did, and I put it in a socket because then it's easier for me to poke around and play around with all this. And now, look at that. Nice. No more problems. No more ripple. Nice and shiny. The reason why it blinks a little bit here, that's actually the camera shutter. I don't see this in real life. Now I came here to say I was done with this scope, but then I started to play a little bit. Look at that. Ugh. I forgot to clean the contacts. Oh, look at that. So I'm not completely done yet. I've been cleaning all the contacts, and now all this seems to be working really good and nice and stable. The only problem is actually the two position potmeters here. They're a little bit unstable. I really tried to clean them so good, but it seems to be moving a little bit. It's also very, very sensitive in XY mode, because of course the error is added to the picture, right? So if there's any error here and any error here, it's gonna get worse, right? And also the signal is quite zoomed because it's occupying the whole screen, right? So that is of course also why it's very visible. But that is the last thing. I've actually added a 20 microfarad capacitor on the potmeter to slow down so it's not noisy, but it's nice and stable. So I think this scope is nice and useful. Again, I'm actually quite happy about this nice and sharp picture. I just got another little nice 3D graphics. Thank you very much, Nikolai, for making this super nice graphics for me. It runs super smooth. I just cannot let this go with the position potmeters. So channel 1 is at the top, channel 2 is at the bottom. If you note all those instabilities and funny stuff that is going on with channel 2, it's because channel 2 is still using this pot, but channel 1 is nice and stable. So what I've done here is, this is the potmeter here that I put in, and it is, let's show you what's going on here. See, this is my pot. So if I put it somewhere, and then let's measure the potmeter voltage on another scope. So now I'm playing around here with this. I'm in AC, by the way, so it should of course go back to 0 like that, right? So this is the set voltage for channel 1, right? Here is the wire for the other one from the inside of the scope. Look at that noise. So this is a voltage per division. Let me go a little bit closer. So isn't that just weird? We got this funny noise going on like that from a potmeter. Look, what the heck is going on? And if I dial it a little bit up and down, put it wherever I want, I got some low frequency and high frequency and funny like that. What the heck is going on? And this is just a potmeter. Crazy. So of course I need to change those 2 pots, but it's just this type of noise. I've never seen anything like that before. And none of the other pots, they're not doing anything like this. And it is of course creating this really weird, unstable position that you see here. I just cannot believe it is that bad. So after I've been fighting around with the potmeters, I just really accepted the fact that I need new pots. But I cannot find the correct order codes in the data sheets or anything from the scope manual. So here is my own specifications for that pot. So it's of course a 6mm diameter of the shaft, and I got the 20mm length, and I got about the 20 kilos. I got this 6mm displacement. That is important. Pin spacing is 3.85 millimeters, and the 10 millimeters from the center of the shaft to the top of the PCB. That is of course very important. And then the width of the potmeter is about 12.4 millimeters. That is not that important, but at least this is my specifications. So now I'll go and hunt down some pots online. Oh, look at that! What just came in? Mauser! That will be 2 new potentiometers. Haha! For my scope! They are of course not perfect size and all that kind of stuff, but that was the closest I could get. But the knob fits perfectly fine, but you see, it's not really the correct length. but I think I will be able to push the knob and give it a tiny little drop of glue. But the feeling here in this pot is really, really good. But it is a lot smaller in the height here, but that means I can just lift it up a little bit, right? As you can see here, it's much smaller on the side. I don't know if I can show this. Impossible. But let me try and put it in and see how it works. So this is the new one and the old one side by side. I think actually I did a quite an alright job. The height is alright. I used this metal solder the thing to the board kind of thingy that holds it exactly where it's supposed to be. So, and the pins there are of course too short, so I had to add a little extra like that. So definitely, yeah, happy it was possible. So this is a new 3D file that I got from Nikolai, so thanks a million times. It runs super smooth. I'm super happy about that. I'm definitely gonna play a little bit with the settings and updates and all that kind of stuff. But now my scope is just super nice and stable and smooth, and it's just staying exactly where I want it. But what I really wanted to show you, I took apart the potmeters, and inside here, inside the potmeter, so I'm gonna put in here a close-up picture of this track, the resistor track and the center connection track, and then there is actually supposed to be some sort of a guard ring or guard track all the way around, in between the center track and the resistor track, and that guard ring is more or less dissolved, and it we can actually see some traces of current that is just going between the resistor track and the center track, and that is of course creating all sorts of noise spikes because current is just going there in some like little sparky shorts and stuff. So this potmeter turned itself into a noise generator, and that is what's been driving me absolutely nuts. So and you can't clean this because it's not on the tracks. It's in between the tracks. So no matter how you clean this, it's not gonna go away, right? Because you need the you need the wiper to move and to kind of move away or push away the problem while you're cleaning. And this is exactly what happened. I did not see any kinds of improvements when I cleaned those pots.